Another kind of question I can give you is kind of a word question, but I've been a little bit generous again. Because of the word description, I didn't actually need to give you that. Let's read it. It says we have a horizontal pipe with a cross section. So what that tells you is that this circle right here is like a sewer pipe or something like that. And we are looking at it straight on. Gravity is going down the way that it normally would. Then I tell you, E is at the center, so that means we can use all of the rules we've been learning. It says the radius is 12 centimeters, and that's how we were able to fill that part in right there. Then it says water fills less than half the pipe, so I can see this is the water level right here. It says the surface of the water, so from A to C, that is 20 centimeters. And it wants us to determine this right here. How deep is the water? Now, where a lot of people will get messed up is they will look at the line from E to B and think that that is the radius. That is not, because it doesn't go all the way to the outside. But we are going to be able to use it. Because let's say, if we are looking at this line right here, I know that that whole thing is 12 centimeters. But I'm not interested in the whole thing. I'm only interested in that much right there. Let's say that I knew this blue chunk of the line. If I knew that that was 10, and the whole thing has to add up to 12, well then that means the red part is 2. If I knew that the blue was, let's say 6, and again we have to add up to 12, that means this is also 6. So my strategy here is going to be, can I figure out that length right there? Because then I can go 12 minus whatever that answer is, and that will give me the length from B to D, which is the depth of the water. Okay, so that's our strategy. We said this whole distance is 20 centimeters, so if I only take half of it, that'll be 10 centimeters. We have a radius intersecting a chord perpendicular, gives us a 90-degree angle. That should make me think of this. Now I need to identify legs. This is a leg. This is not a leg. That's across from my right angle. That's the hypotenuse. So we've seen this quite a few times lately, where B is the thing that we don't know. And if you need me to go through this slower, you've got two options. One would be come talk to me during office hours. Your other option would be go back to the last lesson when I went through all of these, explaining every step. But I don't want these videos to get too long, so I'm just going to cruise through it a little bit quicker. We get B equals 6.63 centimeters, which again is not your answer. You need to go back and think, what does that number actually mean? That fits in right there. I'm not looking for that though. I'm looking for this right here. So I'm going to go, if this whole length here is 12, because that was the radius, let's take out that 6.63. That gives you an answer of 5.37 centimeters, which is this distance right here. And if I compare that to the scale of everything else in this question, that kind of makes sense. It's about the right number. So what I've got on this next page is a question that is very, very similar. Same thing as before. I'm going to get you to pause the video right here, and then after you have your answer, come back and we will compare together. So same thing, we have this radius right here. I know that this distance is 27.5 centimeters. I want to know how deep is that water. And I know that this whole thing altogether is 16 centimeters. So my strategy is going to stay the same. I need to figure out what E to B is. And then after I do that, I can subtract it from the total, and that will just give me B to D. If, in order to figure this part out, identify my right angle, 27.5 divided by 2 to get this side length right here. And now it's Pythagorean theorem. So we have the depth of this water should be 8.18 centimeters.